we are having this question: how much network is required to accelerate a 1,200 kilogram car from 10 meter per second to 15 meter per second? If you listen to the question, we have a car that has a mass of 1,200 kilogram, right? Now, they're asking you how much work is needed to accelerate this car from 10 meter per second to 15 meter per second. Now, for the fact that this car is in motion, we have to consider, and they're asking us for work. Work is also seen as energy. They have the same formula. First times this is in motion, we have to consider mechanical energy. We have two types of mechanical energy: potential energy and kinetic energy. But since the car is moving, we have to consider kinetic energy, because kinetic energy is the energy of the body due to what? Motion. That's due to virtue of its what? Motion. I hope it makes sense. So what's the formula for kinetic energy? Kinetic energy has the formula Ke is equals half mv squared. Does it make sense? Now the first velocity they gave us is 10 meter per second, while the second one is what? 15 meters per second, right? Hope it makes sense. So we have to calculate the kinetic energy when it was moving with this velocity, and the kinetic energy when it was moving with this one. So the first kinetic energy, Ke1, is equals half m, that's mass. They gave us the mass of the car as 1,200 kilogram. So Ke1 is equals half m, mass is 1,200, times v squared. That's the first velocity. 10 squared is 100, right? So 2 here, 1, 2 here is what? 600. So the first kinetic energy is equal 600 times 100 will give me 60,000 joules, right? So what of the second kinetic energy? The second kinetic energy, K is equals half mv squared as well. That half times mass, 1,200. But the velocity now is 15 meter per second. That 15 squared will be 15 times 15. That will be what? 225. 2 here, 1, 2 here is 600, right? So the second kinetic energy is equals 600 times 225. Again, will give us 135,000 joules. So they asked us to calculate the net work, and listen, energy is also work. So that's the net kinetic energy. Does it make sense? That will be required to accelerate, that's to move the car moving with what? That have 60,000 joules, and what? The one have, as in when it will be having 1,135,000 joules. Now the net work now be the second, that's the highest work, minus the lowest work. That's the second kinetic energy minus what? The first kinetic energy. The kinetic energy when it was moving with 15 meter per second minus the kinetic energy when it was moving with what? 10 meter per second. So I have Ke what? 2 minus what? Ke1. So the net kinetic energy becomes Ke2, 135,000 minus 60 what? Thousand, because we got this one to be 60,000, right? So the net kinetic energy is equals 135,000 minus 60,000 will give us 75 what? Thousand. So our answer is 75,000 what? Joules. If you would like, keep it in standard form. It is 7.5 times 10 raised to power what? 4 joules, and that's our what? Answer. Have a nice day. Like, comment, share, and follow Courses Academy. Bye bye.